In this video, I'm going to talk about ARP, or Address Resolution Protocol. And here's an overview. The Address Resolution Protocol, or ARP, was developed to enable communications on an internetwork and is defined by RFC 826. Layer 3 devices need ARP to map IP network addresses to MAC address addresses so that IP packets can be sent across networks. Before a device sends a datagram to another device, it looks in its ARP cache to see if there is a MAC address and corresponding IP address for the destination device. If there is no entry, the source device sends a broadcast message to every device on the network. Each device compares the address to its own. Only the device with the matching address replies to the sending device with a packet containing the MAC address for the device, except in the case of proxy ARP. The source device adds the destination device MAC address to its ARP table for reference, creates a data link header and trailer that encapsulates the packet, and proceeds to transfer the data. The figure below illustrates the ARP broadcast and response process. So this is basically the process. I need the address of, um, let's say in this example that Fred wants to ping Barney. Fred needs the MAC address of Barney for before it can perform a ping. So Barney replied, I heard that broadcast the message is for me. Here is my MAC address. And when the destination device lies on a remote network, one beyond another layer 3 device, the process is the same, except that the sending device sends an ARP request for the MAC address of the default gateway. After the address is resolved and the default gateway receives the packet, the default gateway broadcasts the destination IP address over the networks connected to it. The layer 3 device on the device network uses ARP to obtain the MAC address of the destination device and delivers the packet. I'm going to use this topology. I only have R1 and R2, and they have layer 3 connectivity between each other. So going here to my notes, of course, I got all this from this document. So it says how to configure ARP. By default, the ARP resolution protocol feature is enabled and is set to use Ethernet encapsulation. But of course, we are going to try to follow this procedure on how you can actually uh, configure it. So, and then ARP, and you have these options. So ARPA is um, standard ARP protocol. So enables encapsulation for an Ethernet 802.1 network. And there's other encapsulations uh, for frame relay, and SNAP is for FDDI and Token Ring networks. But of course, most of the networks are, I mean, we are actually using ARPA, right? Usually on our networks, of course, and when you are using Ethernet, of course. And yeah, that's how you can specify it. But of course, it is enabled by default, so I don't have to worry about it. So it's here. and the default timeout is actually 4 hours. Of course, you can also modify that if you want. And of course, this is how you clear the ARP cache. This is how to clear the ARP for a particular interface or on the interface. And here is to clear the dynamic ARP, dynamic entries from the ARP cache. The first switching cache, and the IP route cache. And this is the some commands that you can use to verify ARP. Don't have to put that there. Okay, so this to display the type of ARP being used on a particular interface and also display the ARP timeout value. Here to display the contents of the ARP cache. Let me do this. Okay, so as you can see here, I only see my MAC address or R1's MAC address, I mean IP address in the ARP cache. And it's actually the same. Yeah, same. And here, let me see. Yeah, so it says here to display ARP and RARP processes. So yeah, ARP input, ARP background, etc. Okay, let me actually demonstrate how ARP works. So as we discussed here, um, so you see here that R1 does not have the MAC address of R2 yet. So I'm gonna ping our R2 IP address, which is .2, and what will happen is, yeah, see here that there's a timeout, and that is because of ARP. And and if I do or show IP ARP, now I see the MAC address of R2 here. And of course, its IP address. Go to R2. Yeah, oops. Yeah, this is the IP address, and the MAC address should be. Let's see. I think the MAC address of this interface. Let's verify that. Yes, so same. 7300. So same here. So that's the MAC address of gigabit 0/0 of R1. And of course, R2, I should say. And of course, R2 should be able to see the um, R1's IP address in its ARP table, which is here. And if I show interface, I will see the MAC address of R1, and that's here, C3, yeah. Yeah, that's how you can configure ARP on Cisco iOS. Let me see, I'm thinking let's try to reboot this, reboot R1, or actually both devices, because I want to capture, what's I want to start capturing the traffic on the interface while ARP is in action. Let's just wait. I think it will take a while. Yeah, while the devices are reloading, let me just check this document. So, are they still reloading? Yeah. IP addressing occurs at layer 2 or data link and layer 3 um, network of the Open System Interconnection or OSI reference model. OSI is an architectural network model developed by ISO and ITU-T that consists of 7 layers, each of which specifies particular network functions such as addressing, flow control, error control, encapsulation, and reliable message transfer. Layer 2 addresses are used for local transmissions between devices that are directly connected. Layer 3 addresses are used for indirectly connected devices in an inter-network environment. Each network uses addressing to identify and group devices so that transmissions can be sent and received. Ethernet 802.2, 802.3, Ethernet 2, etc. use media access control MAC addresses that are burned into the network interface card or NIC. The most commonly used network types are Ethernet 2 and SNAP. For the supported interface types, see the datasheet of your hardware platform. Okay, so it's just talking about the frame relay network. Let me see if they have, I think they have reloaded. Okay, before I actually perform a ping, I'm going to start capture, and instead of ping, let me do telnet instead. Oops. Yeah, so port 23 is open. Let's see. Now we have R2 IP address in the ARP table or ARP cache, and we should have our one IP address in on R2 ARP cache table as well. Let me stop and just filter for ARP. I think there is a info. Yeah, here. So this is ARP in action. So we see that we performed the telnet from R1, right? Let's see. R1. R1's MAC address is this. Yeah, so R1 sent a broadcast, and this is the ARP packet. So sender MAC address is this, which is correct, and sender IP address is this, which is correct. So target MAC address is broadcast, which is all 0, and target IP address is R2 IP address. Let's check the reply. So sender, let me go to R2 and check the MAC address. Yeah, so see here 73, it ends in 7300, which is R2, which is the IP, the MAC address on gigabit 0/0 on R2, correct? And sender IP address is R2 IP address, of course, and target is the one that we saw earlier here. And target IP address is R1's IP address. So basically the info here, um, who has the MAC address of this IP address? Uh, Tell me, or tell R1. And R2 replied, and it gave the and it says R2 or that 2 is at this IP address. And if you go here, I mean MAC address. So yeah, same. Yeah, we can see that it's reply here. And we see that that the target MAC address is again all zeros. Um, Actually, here we see that the destination is broadcast, which is um, all F, right? So let me back up, because when you say broadcast, it's actually all F, right? I believe it's showing us all zeros here because it doesn't have R2's MAC address yet. And if we go here, R1, yeah, it should be the same. And let me go destination. No, go back here. Yeah, ARP. So destination MAC address is this, which is correct. Source is this, which is correct. Okay, looks good. Yeah, that's ARP in action.